Hi, I'm Yifan Zhang, and I'm going to explain question 3 from the final exam in CSE2 Spring 2014 semester. Question 3 is asking us to state the output when the method Q10 is called. Besides the main method, which is not shown in this question, there are 4 methods in this question, and they are Q10, print, conundrum 1, and conundrum 2. To state what is going to be printed, you should understand each method, which is testing you on different aspects of Java language, such as methods, array, if statement, switch statement, keyword break, for loop, and while loop. To be more specific, this question is really testing on: does the student understand how pass-by value works for arrays when an array is passed to a method? What will happen if an equal operator is used to set two arrays equal? How a switch statement will execute with or without a break statement? Will the use of break statements cause a fall-through behavior, and how will that affect our output? What is the function of the break statement when it is used inside a loop? In order to answer this question correctly, it is important for you to fully understand these concepts, which I'm going to explain next using slides. Let's go through these concepts. Java uses pass-by value and passing arguments, which are input variables, to parameters in a method. In other words, the input variables are not directly passed to the parameter. Rather, it first creates a copy of the value of the input variable, and then that copy value is passed to the method. Pass-by value works for all variables, no matter this variable is of the primitive data type or is an array. However, I do have to point out that there's a slight difference between the pass-by value for primitive data type variables and arrays. For primitive data type variables, which include byte, short, int, long, float, double, boolean, and char, the value of the arguments, which are input variables, are first copied, and then these copies are passed to the parameters. Thus, modifying a copy does not result in a change to the variable that was passed into the method. For arrays, the reference value, which is the memory address of the input array, is first copied, and then this copied reference value is passed to the parameter. For easier understanding, we could think of an array that has a pointer pointing to a location of the object data, and that pointer is equivalent to the array's memory address. So, the effect of pass-by value for arrays is that the array in the method is now referring to the same input array, but it has a different name. Thus, since these two arrays are pointing at the same location where the data of the array is stored, modifying the array in the method will result in a change to the input array after the method finishes. Let's take a look at an example of passing an argument of a primitive data type variable. Here, in the main method, we have integer variable of num1 equal to 3 and num2 equal to 5. And we are going to print out the value of num1 and num2. Then, we call the method of swap, which have input variables of num1 and num2. We then have another print statement to help us understand if the values of num1 and num2 are changed after the swap method. Since num1 and num2 are of integer type, which is one of the primitive data type variables, when we have them as the input variables of the swap method, we are first copying their values and then passing these copied values to the matched parameters of n1 and n2. So, the value of num1, which is 3, is copied and passed to n1, so n1 is equal to 3. And also, the value of num2, which is 5, is copied and passed to n2, so n2 is equal to 5. Inside the swap method, we have temp equal to n1, so temp is equal to 3. We also have n1 equal to n2, so n1 is equal to 5, and then n2 is equal to temp, so n2 is equal to 3. So it seems like we've done the swapping for n1 and n2 inside the swap method. Meanwhile, you can easily find out that the changes that we make to swap the values do not apply to num1 and num2 in the main method, so their values remain the same. When this method ends and we go back to the main method to print out the value of num1 and num2, we're going to find out that num1 and num2 are still printing out the same value. So this example shows us that when passing primitive data type variables to a method, the changes we make inside the method does not reflect outside in the main method. For comparison, here's an example of passing an array. In the main method, we have an integer array which contains the first element of 3 and the second element of 5, and we're going to print out the value of x at index 0 and index 1. Then we call the swap array method and have another print statement printing out the value of x at index 0 and index 1 to find out whether their values are changed after calling the swap array method. So we have the integer array of x initially pointing to a location where the elements of the array 3 and 5 are stored. We could think of this pointer as a memory address of the array. When we have x as the input variable for the swap array method, since x is of array type, its reference value, which is its memory address, which is equivalent to the pointer, is copied, and then this pointer is passed to the parameter list. Therefore, list is now pointing at the same location where x is pointing to. Inside the swap method, we have temp equal to list of 0, so temp is equal to 3. And then we have list of 0 equal to list of 1, so list of 0 is equal to 5. And then list of 1 is equal to temp, so list of 1 is equal to 3. Since list and x are pointing at the same location, the changes that we made to the array list also applies to the array x. When we go back to the main method and tries to point out the value of x for index 0 and index 1, we're going to find out that these values are changed. This example of passing an array to the method shows us that the changes that we make inside the method persist outside in the main method. When we use an equal operator to set two arrays equal, what will happen is that the copy of one array's memory address is assigned to the other array. So what it really means is that two arrays are pointing at the same location of the object data. Let's use an example to explain this. In the main method, we have integer array of x, y, and z pointing to three locations of object data. This is shown by black arrows. Then we call the change array method and pass the variable x, y, and z to parameters array 1, array 2, and array 3. Based on our discussion on pass by value for arrays, these arrays inside the method are now pointing at the same location where x, y, and z are pointing to. Then we use an equal operator to set array 1 equal to array 2. What this step means is that we are copying the pointer that array 2 is pointing to and assign that copied pointer to array 1. Therefore, array 1 is now pointing at the same location where array 2 is pointing to. Then, when we are changing the index 0 of array 1 to 1000, the change actually reflects in the location where array 1 and array 2 are both pointing to. Also, we have array 3 equal to array 1. What this means is that we copy the pointer where array 1 is pointing to and assign that pointer to array 3. As you can see, array 3 is now pointing at the same location where array 1 is pointing to. Also, it is where array 2 is pointing to, since array 1 and array 2 are pointing at the same location. So, when we change the index 1 of array 3 to 200, the change reflects in the location where all three arrays are pointing at. This shows that even though we are not directly modifying array 2, but because array 1 and array 3 are both pointing at the same location where array 2 is pointing, their changes reflect in the elements of array 2. When we go back to the main method and use the print array method to print out each element in the specified array, we are looking at the original black arrows where array x, y, and z are pointing to. So we have the output of array x, y, and z, and we can see that the changes we make inside the method still exist in the main method. A switch statement is in the format like this. The switch expression can be byte, short, char, and int primitive data types. The value 1, value 2, until value n must have the same data types as the value of the switch expression and are constant expressions. The statements starting from the case with the matching value of switch expression are executed until reaching the break statement or the end of the switch statement. and this is called a follow-through behavior, which I will explain later. The default case is executed when none of the specified cases matches the switch expression, and the break statement immediately ends the switch statement. The follow-through behavior is due to the fact that once a case is matched, the statements starting from the matched case are executed until a break statement or the end of the switch statement. What this means is that if some break statements are omitted, the statements will continue to run through the following cases even though their values in the case statements do not match with the switch expression. So here's a very simple case of the switch statement. Suppose we switch the value for the day, and we omit the break statements for day equal to 1, 2, 3, 4, and day equal to 0. And what will happen is that no matter if day is equal to 1, 2, 3, 4, 5, it will always print out weekday because it will follow a follow-through behavior until reaching the break statement in case 5. And if we have day equal to 0, it will follow through again, and it will stop until reaching the end of the switch statement, and then it will print out weekend. So we have break statement inside a switch statement, and we can also have break statement in the loop. When we are using a break statement in a loop, it will immediately exit the loop. Suppose we have a while loop with certain conditions and an if statement with certain conditions inside the while loop, and inside the if statement we have a break statement. So when we meet the condition in the if statement and it will reach the break statement, what will happen here is that it will immediately terminate the loop, and this is shown by the arrow here. Now let's look at the actual exam question, which is asking us to state the output of calling method Q10. When we call conundrum 1 with input variables a and 4, the values a and 4 are copied and passed to ch and n. The switch statement switches the value of ch. Since in this case, ch is equal to a, it matches case a and goes to the while loop. Because it is true, it prints out the value of n with a space. Initially, the value of n is 4, so it prints out 4 with a space. And then n is decreased by 1, so n is equal to 3. Since it is still true, it prints out again the value of n, which is 3 with a space. And then this value is decreased by 1 again, so n is equal to 2. It will continue to go through the while loop and print out the value of n, and then decrease n by 1. So 2 followed by a space was printed, and then n equal to 2 is decreased by 1. So 1 followed by a space is printed, and then n is decreased by 1 again, so n is equal to 0. When n is equal to 0, it matches the condition in the if statement, so it will reach the break statement. Remember that when there's a break statement inside the loop, it will exit the loop immediately, so it terminates the while loop, but it is still in case A, as shown by this arrow here. Since there isn't a break statement for case A, it causes a follow-through behavior to run through case B, and it is going to print out at B. Since when we print for the value n are on the same line without starting a new line, the at B is going to print out on the same line with 4, 3, 2, 1, and then it starts a new line. It now reaches the end of the switch statement, so it will leave the switch statement and then goes back to the main method. Then we call conundrum 1 method again, but with arguments b and 2. These arguments are passed to the parameters ch and n, so ch is equal to b and n is equal to 2. The switch statement is going to switch the value of ch. Since ch is equal to b and this matches the case expression, it goes into case b and is going to print out at b. Then it reaches the end of the switch statement and go back to the main method, and turns to calling conundrum 1 method again, but with input variables c and 3. Since there isn't a listed case c inside the switch statement in conundrum 1 method, and it also doesn't have a default case, so nothing is executed and we turn to the main method. Then we call the print method and have input variable of the integer array x. Inside the print method, it will go through the for loop that iterates from j equal to 0 to j equal to 4, since the length of the array x is 5, and the loop continuation condition is j less than 5. So it is going to print out each element in the array x with a space separating two elements. Then we do the same to array y by calling the print method. So Each element in the array x and y are printed before calling the conundrum 2 method. It then comes to the part of calling the conundrum 2 method. The first input variable is x of 1, so parameter x is equal to the value of the integer array x at index 1, which is 2, so x is equal to 2. And then we pass the array x and y to parameters y and z. Integer array x and y are pointing at the location where the elements of the array are stored. Then, pass-by-value for arrays allows us to copy each pointer and assign them to the parameter y and z. You have to be careful without messing the names of the arrays in the method and the arrays in the main method, since they might have the same name, but they are actually different arrays. So, y is now pointing at the same location where array x in the main method is pointing to, and z is pointing at the same location where array y in the main method is pointing to. Inside the conundrum 2 method, there is an integer array temp, which is set equal to y. So, we copy the pointer that y is pointing to and assign that copied pointer to temp. Therefore, temp is pointing at the same location where y is pointing to. After that, we increment x by 2. As x is initially equal to 2, this means that x is now 4. Make sure that x is an integer here in the conundrum 2 method, and do not confuse it with the integer array x in the main method. Then we use an equal operator to set y equal to z. What this means is that we copy the pointer that z is pointing to and assign that copied pointer to y. Therefore, y and z are now pointing at the same location. Then we add 5 to z of 1, so z at index 1 is now 13. After that, we print out the value of x, which is 4. And then we use an equal operator again to set z equal to temp. This means that we copy the pointer that temp is pointing to and assign that copied pointer to z. So, z and temp are now pointing at the same location. It means that when changing the index 3 of array z, the change actually reflects in the location where both temp and z are pointing to. The value of array z at index 3 is now changed to 42. As it reaches the end of conundrum 2 method, it goes back to the main method. The next line calls the method of print and have array x as input variable. As we discussed before, this print method prints out every member in the input array with a space separating two elements. Therefore, it is going to print out the elements that the black arrow is referring to. Note that because of passing array to methods, the changes we make to the arrays persist outside the method, so it is going to print out the array x with the changes that we made inside the conundrum 2 method, so it will print out 1, 2, 3, 42, and 5. This works the same for array y, which is going to print out the array with changes we make, so it prints out 7, 13, 9, and 10. So let's now compile and run this program to see if it generates the same output that I've run before. Here on Code Anywhere, I copy and paste the 4 methods listed on the exam, and I added the main method, which is calling method Q10. I'm going to open the terminal here, and I'm going to type in the commands. And now I'm going to compile it. Yeah, and I'm going to run this program. So as you can see, this generates the same output that I have explained before. Let's look at a more difficult version of passing arrays to methods and stating the output. I'm going to call conundrum 2 method twice, and have the first time calling this method returning an integer so that this integer value can be used as an input variable during our second call. Since the conundrum 2 method in this question is a void method, which means it is not returning anything, I'm going to change it into an int to let it return an integer. And I'm just going to let it return the value of x, which is incremented by 2 in this method. So when you look at this line now, it will return an integer, and as we have discussed before, when calling it once, it will return the value of 4. So I'm just going to use it as the first input variable, which matches the parameter x, because they are of the same integer type. So I'm just going to add the name of the method and then have it as the first input variable. And because I have to keep the number and type of the other variables the same to the parameter, I'm just going to add x and y to match the array in the parameter. So what will happen if we call conundrum 2 method twice? When calling it once, it will result in a change to the array x and y that persists in the main method that we have discussed before. And now, since we let it return a value, this will return a value of 4. When calling this method the second time, the value of 4 is copied and passed to the parameter x. And so, as x is incremented by 2, it will print out the value of 6, and then it will return 6 at the end. Meanwhile, we are making the same changes to array x and y again. Recall that the first change results in the 42 at index 3 of array x, and the second change results in the plus 5 to index 1 at array y. So what will happen if we call it twice is that this 42 will still remain 42 even though we change it again, and then we will add another 5 to 13, so it will be 18. And also it will print out a 6 during the method. So let's now compile and run this program to see what will be our output. So let's type in the commands and let it compile and let it run. So as you can see, it first print out a 6 during the process, which means that x is incremented by 2, and it then prints out array x and array y, and you can see that the index 1 at array y is incremented by 5. So this example shows us that we could call the same method twice if the number, order, and compatible type of arguments match the parameters, and also the changes to the arrays inside the method persist outside in the main method and will carry on to our second call to the method. There are some misconceptions for this question. When I was first doing this question and I saw the break statement inside case A, what I saw was that this break statement will break case A completely, so it won't cause a fall-through behavior to run through case B. However, this break statement is actually inside the while loop, so when the program runs through this line, it will immediately exit the while loop, and it will still be inside case A, and it will cause a fall-through behavior. Another possible error is to mess up different variables in the two methods because of the same name. So the question here has integer array y in the main method, but it also has another integer array y in conundrum 2 method. So when passing the array to the array y in conundrum 2 method, we are actually passing the array x in the main method. However, because of the same name, it is possible for some students to mess up with which array we are actually passing to. Another part of the question where students might get it wrong is that in this question, there are a lot of equal operators to set two arrays equal. While this step means to change where one array is pointing to the position where the other array is pointing to, some students might let the array point to the wrong position. Therefore, when modifying the elements in that array later, because it is already pointed to a wrong location, the changes made afterwards will be wrong. There are some advice for doing this type of question. The first one is to determine if calling the method will generate a compare error before you do this question. So this compare error generally comes from a mismatch between the order, number, and compatible type of the arguments and parameters. If you skip this step and continues to do the problem, you might find out sooner or later that at some point, the statements does not make sense and will cause compare errors. This is even more relatable when calling the method twice. During the second time of call, if the return value type of the method does not match with the input variable, for example, so all the previous work is just useless and this wastes time during an exam. The second advice is to draw a diagram showing the pointers. When I'm doing this kind of questions, I always find it helpful to draw a diagram of arrays having pointers point to several locations, and then I can erase and change the position of the pointers just like what I've shown before. In this way, it visualizes the relationship between every array and makes it easy for me to determine where I should modify the elements in the array. And the third advice is to go through each step slowly and carefully. In this way, it will allow you to see where the break statement is functioning. Maybe, is this break statement for the loop, or is it for the case in the switch statement? Also, it will reduce the chance of messing up with different arrays in two methods that have the same name, as well as letting the pointers point to wrong locations, and lots of other careless errors that could have been avoided. Therefore, during an exam, try not to rush through the question, but to take your time to examine the effect of each statement. There is an additional advice when you are practicing this type of question is that when you are not sure if you state the correct output, you could try adding some print statements to the points that you feel like this is where you get it wrong. You could also try to add some test statements to examine if there are some differences to the output by adding this statement. For example, in this question, you could try adding a break statement at the end of case A, and the output will show that one of the add B print statements disappeared, and this means that the fall-through behavior is avoided by adding the break statement. There are some similar questions for you to practice passing arrays to methods and stating the output, and they are from Spring 2014 Exam 3 Question 5 and Fall 2014 Exam 3 Question 5. For practicing more use of arrays and methods, you should definitely try doing more Exam 3 and final exam problems. I'm Yifan Zhang, and this is CSE2.